Welcome back. In our last few classes, we have already solved a few problem sums based on addition, subtraction, multiplication and division of algebraic expressions. In today's class, we will be solving a few problem sums based on algebraic identities. These are the four problem sums that we will be solving in today's class. But before that, let's revise the standard identities. Now let's solve the first problem sum. Here we have 3x plus 7 square of that term minus 84x, and we have to prove that that is equal to 3x minus 7 and square of that term. So we will start our processing from the left hand side. Here you can see that 3x plus 7 and square of that term. So it resembles the identity a plus b whole square, right? So, and we know this is identical to a square plus 2ab plus b square. Now here 3x can be taken as or can be considered as a, and 7 can be considered as b. So 3x plus 7, it fits this identity a plus b and then square of that term. So if we go by this identity, then it can be written as a square means 3x whole square plus 2ab. So 2 here, 3x is our a and 7 is our b, as I said, as we took. Now b square, so it will be 7 square. Then we already have this term 84x, so we will be writing that term also. Now it is 3x plus 3x square of that term, so it will be square of 3 means 9 and x square, so it will be 9x square. Then we have 7 here, 3, 21, 7 3s are 21, then it is multiplied by 2, so it will be 42. So here the term will be 42x. Then we have square of 7, so it will be 49. Then we have minus 84x. So the terms again we will be simplifying and arranging according to their power of the variable, which is x here. So we will be writing 9x square first because we don't have any other x square term. Then we have 42x and here minus 84x. We have these two like terms, and we have already seen how to add the terms in case of algebraic expressions. So simply their coefficients will be algebraically added, means we will be taking plus 42 and then we will be considering minus 84, and x is the common factor, that is the like term, so we will be writing that way, and then 49. So 42 minus 84, it will be minus 42. So first we will write 9x square, then from here we will be getting the term minus 42x and then 49. Again we can arrange these terms this way. 9x square means we have seen that is the square of 3x, so we can take this as square of 3x. Again 49 we have already seen that this is square of 7, so we will be writing accordingly. Then this can be written as 2 multiplied by 3x multiplied by 7, because we have already seen that 2 multiplied by 3x multiplied by 7, that gave us 42x. So here also we have 42x, only difference is here we had plus sign, here we have minus sign. So we can arrange this way, 2 again 2 multiplied by 3x multiplied by 7. So now it seems, it looks like this formula, this identity, that a square then minus 2a, here again a is our 3x and b is 7, then multiplied by b and then b square, and that is equal to, we know, a minus b whole square. So this can be rewritten as a minus b whole square in that form, that means 3x minus 7 and then square of that term, and that's what we wanted to prove. Next we will solve the next problem sum, which is given as 4m divided by 3 minus 3n divided by 4 and whole square of that subtraction of these two terms, then plus 2mn, and that is equal to 16m square by 9 plus 9n square by 16, that we have to prove. So again we will start our processing from the left hand side. Here again we will assume or we will consider 4m divided by 3 as a variable variable a and 3n divided by 4 as b. Now if we look at this square term, then it is a minus b then whole square of that term. So we know this identity that it is a square minus 2ab plus b square. So we can write this way, a minus b whole square. So it will be first a square, so 4m divided by 3 then square of that term plus b square, or maybe minus 2ab we can write. So I'm writing a square then plus b square minus 2ab. So a square then plus b square means 3n divided by 4 then whole square. Then I will be writing the second term which is minus 2ab. So here it will be 2a, in our case it is 4m divided by 3 and b is 3n divided by 4. Then we have already this term 2mn that we will be writing to complete that line. Now 4m divided by 3 and square of that. Separately we will take the square of all the constant term or variable that we have. So square of 4 means 16, then square of m square, then in the denominator we have 3, so square of 3 means 9, and then here we will be writing square of 3 means 9, then n square, and in the denominator it will be 16 square of 4 minus here 4 we have in the numerator and also in the denominator, so they will cancel each other. They will cancel each other means 4 divided by 4 is 1. So as if we have 1 in the numerator, then 3 and 3 will cancel each other as if we have again 1 in the numerator. We are dividing 3 by again 3. So here finally it will be 2 then 1 and m. That means straightforward we will be writing m, and then 1 multiplied by n, so straightforward we will be writing n only. Then again we have term 2mn. Now in the next line what we will be writing, what we can see here, the third term and fourth term are same, only difference is their sign. So minus 2mn and plus 2mn will cancel each other. Only terms that will remain in that expression is 16m squared divided by 9, and then the second term 9n squared divided by 16, right? And that's what we had on the right hand side, and that's what we wanted to prove. Now we will be solving our next problem sum, which is given as 4pq plus 3q whole square minus 4pq minus 3q whole square. We will assume that 4pq plus 3q as a new variable a and 4pq minus 3q as our new variable b. So if we replace these two terms means the first term itself is 4pq plus 3q, summation of two other terms, so that we are assuming as a, and the second term, difference of the same two terms, we are assuming as b. So as if it is looking like a square minus b square. So we already know this identity that a square minus b square is nothing but it's simply a plus b multiplied by a minus b. So here we will be again putting we'll be writing or using that identity a plus b multiplied by a minus b. That means now if we replace again a by its original term, so it will be 4pq plus 3q then plus b. B is what? B is 4pq minus 3q. 4pq minus 3q. So that term will be multiplied by a minus b. So here what is a? 4pq plus 3q, and what is b? B is 4pq minus 3q. So when we will be subtracting, it will be minus 4pq and then minus, and we already have minus here. So minus of 4pq minus 3q. What it is? It is minus 4pq then minus plus 3q. So straightforward we will be writing minus 4pq and then plus 3q. Now we will be simplifying the terms. So here minus 3q and plus 3q, since these two terms are same, only difference is the sign, so they will cancel each other. Only term that will remain here is 4pq plus another 4pq like terms, so their coefficients will be simply added, so it will be 8pq. Now in the second term within the bracket what we have is 4pq minus 4pq. Again the terms are are same, only difference is sign, so they will cancel each other. And here 3q, again another 3q like term, so their coefficients will be simply added, so it will be 6q. Now we will be multiplying these two terms. So first we will multiply, we have gathered the knowledge of multiplication of algebraic expressions, so simply their coefficients will be multiplied here. 8 6 are 48, then p, and here we don't have any more p, so it will be simply p, and q, and here we have another q, so q multiplied by q, it will be q square. Their powers will be added, so q to the power 1, q to the power 1, 1 plus 1 2, q square. So this is our answer. Next we have another problem sum, which is this expression. So what we will do is, here we can say we have multiplication of two factors, and the factors are a minus b and a plus b. So what identity we will be using here? We know a square minus b square is equal to a plus b multiplied by a minus b. So here we will think from the opposite side, means from the right hand side of that identity. So here this format is given, a plus b multiplied by a minus b. So we will be writing the term that we have on the left hand side. So a minus b and a plus b, because the multiplication of a plus b and a minus b will give us the same result of the multiplication of a minus b multiplied by a plus b. So here we will be writing what we have on the left hand side, that means a square minus b square. Fine. Then again we have this format, b plus c and b minus c. So what will be the result? Again this format. So here in place of a we will think of b, and in place of b we will think of c. So it will be b square minus c square, and here in between these two terms we have plus sign, so it will be plus b square minus c square. Again we have plus sign, and here again the same format, c minus a, c plus a. So it will be, in place of c we will be thinking of a, and in place of a that will be mapped with b. So it will be, again we will be using this identity. Here the result will be c square minus a square. Now what we can see is this expression. So here what we can see, a square, and we have another a square with negative sign. So plus a square and minus a square will cancel each other. Minus b square, again we have plus b square, again they will cancel each other. Minus c square and plus c square, so they will cancel each other. So nothing remains in that expression. That means the final answer will be 0. So this is how we simplify problem sums based on algebraic identities. In our next class also we will be solving a few more problem sums based on algebraic identities. Till then, stay safe and stay healthy. Thank you.